Assalamu alaikum wa rahmatullahi wa barakatuh. Dear viewers, welcome to all of you in Basic Piping and Welding course class. Today I am going to be start lecture 20. So in this lecture also I try to discuss with you about the welding imperfection. So related to welding imperfection, this is the second lecture. And you are watching from YouTube channel Nur Muhammad and Facebook page Watch and Learn. If you still not subscribe my YouTube channel, please don't forget to subscribe to get the all update lecture, and don't forget to share with your friends. Okay, let's see what we have in today lecture. So today lecture we will discuss about the hydrogen induced cracks and lamellar tearing. So first we will discuss about the hydrogen induced cracks. So what is the hydrogen induced cracks and why happened and how we can prevent? These are the things we try to discuss with you in this lecture. So hydrogen induced cracking occurs primarily in the grain quartz region of the H and is also known as cool delay or underbeat or toe cracking. So hydrogen induced crack, actually this is the occurred in the H area, and this is start from 2 or this can be the underbeat is the fusion line there. So that is the reason these cracks we can call the so many name is the hydrogen induced cracks or the toe cracking or underbeat cracking. So this crack have the another name also, the delayed cracking. Why we call the delayed cracking? Because when we do the welding, after welding immediately we cannot observe this type of crack. So for this type of crack we need to wait one certain period to get the crack. So that is the reason we do the any type of NDT after 48 hours, because of we are wait for this type of cracks or this type of defects. So it lies parallel to the fusion boundary and its path is usually a combination of inter and transcellular cracking. So let's see what we have in the next slide. So second thing is the detection of the principal residual tensile stress can in two cracks cause the crack path to grow progressively away from the fusion boundary towards a region of lower sensitivity to hydrogen cracking. When this happens, the crack growth rate decreases and eventually arrests. So for the hydrogen induced cracking, the 4 factors are necessary to cause hydrogen induced cracking. What is the 4 factors? Let's see. So you can see from this right sides. So number 1 is the hydrogen level. So if hydrogen level is greater than 50 ml per 100 gram of oil metal deposited, so this is the hydrogen level, so hydrogen content. Second thing is the stress. If stress is the more than 0.5 of the yield stress, then temperature if less than 300 degrees Celsius, and susceptible microstructure is 400 HB hardness. So this is the hardness. So if hardness is greater than 400 HB, so if these the four things is together is occur, then only we can get the hydrogen cracking. So if we want to avoid to hydrogen cracking, then any of elements or things we need to remove, then we can protect from hydrogen cracking. So this is 4 things is the necessary to cause hydrogen cracking. So must keep remember, this is the very important questions. So let's see what we have the index structure. Next slide. So another thing is the if any one factor is not satisfied, cracking is prevented. So can be avoided through control of one or more factors. So how we can control these the things? So apply preheat, slow down the cooling rate, and thus avoid the formation of susceptible in microstructure. Maintain a specific interpass temperature, same effect as preheat. Then post heat on completion of welding to reduce the hydrogen content by allowing hydrogen to diffuse from the weld area. So this is the things we can control the hydrogen induced cracking. Then apply PWST, post-void heat treatment, to reduce residual stress and eliminate susceptible microstructure. Then reduce oil metal hydrogen by proper selection of welding process consumable. Example, use TIG, TIG welding instead of MMA, manual metal arc welding, basic covered electrode instead of cellulose. So if we use the proper welding consumable and welding process, then also we can prevent hydrogen induced cracking. Then use a multi-run instead of single run technique and eliminate susceptible microstructure by the self-tempering effect. Reduce hydrogen content by allowing hydrogen to diffuse from the weld area. So use a temper bead or hot pass technique, same effect as above. So these are the things we need to keep remember. These are the things if we do, then we can prevent the hydrogen induced cracking. Let's see what we have in next slide. So use austenitic or nickel filler to avoid susceptible microstructure formation and allow hydrogen to diffuse out of critical areas. Then use dry shielding gases to reduce hydrogen content. Then clean rust from joint to avoid hydrogen contamination from moisture present in the rust. Then reduce residual stress. Then another thing is the blend the weld profile to reduce stress concentration at the toe of the weld. So for from toe of the weld you need to the grinding and you need to blend out of the weld profile. Then also we can prevent the hydrogen induced cracks. So here you can see the one picture. So this is the summary of factor affecting the hydrogen core cracking. So you try to understand from here, we try to understand from here. If high plate thickness, if plate thickness is high, then if fast cooling rate, then it can be the hard brittle mercantile structure, then also can be caused the cold cracking or hydrogen cracking. So second thing is also same, low ampere high trouble speed. If welding time we use the low ampere, then high trouble speed, then can be the low heat input. If low heat input, then the fast cooling rate, we know this. Then related to this I will explain to you in another lecture. So another things you can see from here, contamination, dirty surface and rich hydrogen filler. If the hydrogen filler is the, if filler rod is the more hydrogen is there, then also can be the hydrogen contamination. So if hydrogen contamination, then can be the hydrogen diffusion. So hydrogen diffusion, hydrogen trapped in the mercantile lattice, then also can be the cold cracking. So if no preheat or load interpass, then also can be fast cooling rate. Then this is the another things is the poor joint design and fit up. If joint design and fit up is the poor, then also can be the high stress, then also can be the cold cracking. If in material is the carbon equivalent is high, then also can be the cold cracking. So these are the things I try to explain you by one chart. You can read and you can understand also. So okay, let's see what we have in the next slide. I hope you understand this the chart. If you have any confusion, maybe you can ask me in comment box. Okay, another thing is the laminar tearing. What is the laminar tearing? So laminar tearing occurs only in rolled steel. So you need to keep remember this is the occurs only in rolled steel products, primarily plates, and its main distinguishing feature is that the cracking has a traced appearance. So you can see this is the welding bead. So this is also the nearby the two. Okay, then cracking occurs in joint where a thermal contraction strain occur in the through thickness direction of the steel plate. So you can see this is the plate weld configuration. So this is our main plate, this is the another plate, so welding here. So this actually this type of tearing is occur is there here due to the thermal contraction strain. So here is the strain. So the for strain this can be the occur is here. So non-metallic insulation are present as very thin plates with their principal planes parallel to the plate surface. So if the non-metallic insulation is here, then also can be this type of laminar tearing. So another thing is the contraction strain imposed on the planar non-metallic inclination results in progressive decussion to form the rough rectangular holes, which are the horizontal part of the cracking parallel to the plate surface. With further strain, the vertical parts of the cracking are produced, generally by ductile shear cracking. These two stages create the trace appearance of this cracking. So these the things actually the is liable for the lamellar tearing. So two main options are available to control problem in weld joint liable to lamellar tearing. So before we already see why the lamellar tearing actually happened. So now you will know how you can prevent this. So use a clean steel with granted through thickness properties material. So if we use good material, the jet grade material, then we can prevent this type of problem. Then another is a combination of joint design, restraint control and welding sequence to minimize the risk of cracking. So if we do the joint design and welding sequence, if you follow the properly, then also you can control this type of defects. So that's all. This is the that's all the today in lecture. So about today in today lecture, if you have any question, you can ask me in comment section. So I will try to answer your question. So thanks to all for watching today lecture, and see you soon in my next lecture. Allah Hafiz. Assalamu alaikum wa rahmatullahi wa barakatuh.